Okay, guys, I am just going to take up questions 3, 4, 7, and 10 from the assigned homework. I'm assuming that no one had problems with questions 1 and 2. Remember that you have to check to make sure that your computer is on DEG or D. If it's not, you're not going to get the right answers. If I were there, I could help you reset it, but probably the easiest thing is just clear everything from your memory. They should default to degrees, but just give a quick check. If you're not getting the same answers I'm getting, that's probably why. Okay, so for question number 3, it says find the height of the tower to the nearest tenth of a meter. So I'm going to make a sketch. We're assuming that's a right angle triangle. I'm 36 meters here, 58 degrees for my angle, and I'm looking to find x. So remember, with SOHCAHTOA, right? I want to know this, and I know this. So looking at my triangle, let's label that with a different color. Again, this is the hypotenuse. If this is my angle of interest, this is adjacent, and that is opposite. So I don't know the hypotenuse, and I don't want to know it. I'm not actually asking you to find that. I'm actually asking you to find this. So I don't know about the hypotenuse, and I don't care about the hypotenuse, which leaves us with the trig ratio of tan. So what can I say? I can say the tan at 58 degrees equals opposite over adjacent. The tan, I'm just going to leave it tan 58 because most of our calculators can do that. The tan of 58 degrees equals my opposite value, x, over my adjacent value, which is 36. So again, make this over 1 so that I can cross multiply and solve. X times 1 equals x, and I'm left with tan 58 degrees times 36. So you can just plug this right into your calculator. You don't even need to find tan 58. Just do tan 58. It should equal 1.600. I'm going to multiply that by 36, and what I find is that my answer is 57.6. The question asks to find it to the nearest of meter, so I leave it to 1/10 of a meter, so I leave it to 1 decimal place, and that's my answer. Does that seem reasonable? Sure. Okay. So nothing tricky there. Let's take a look at question number 4. I'm going to do a similar question. Got a right angle triangle, except this time I'm telling you how tall the lighthouse is. I'm giving you this angle, and I'm asking you how far, what is this distance? How far is the boat from the base of the lighthouse? So again, I'm not saying that you have to do this, but not a bad idea. This is my hypotenuse because it's across from the right angle. Here's my angle of interest. That means this is the opposite. This is touching, so this is the adjacent. Again, looking at SOHCAHTOA, again, I know the opposite. I want to know the adjacent. I don't know hypotenuse, and I don't care about hypotenuse, so I can get rid of anything that has hypotenuse in it. And again, I'm stuck with tan. So I have the tan of 42 degrees equals opposite over adjacent. Tan of 42 degrees equals the opposite, right? So there's my opposite is 46 over x. Now this question's a little bit different than this one. This one's easy because I can just cross multiply. But over here, look at what happens. When I cross multiply, what I get is tan 42 times x. So I'm left with x times tan 42 equals 46 times 1, which equals 46. Okay, so I'm going to figure out what the tan of 42 is, 42 degrees, and that equals, we do this always to 4 decimal places, equals 46. Now I want to get x by itself. Right now it's multiplied by 0.9004, so I have to do the opposite operation. So I'm going to divide by 9004. What I do to one side, I do the other side. It's just an extra step. So I do 46 divided by that answer, and I get 51.1, and my units were meters, so my answer is meters. Okay, now if we were in class, I would be asking you if you had any questions. I don't hear anyone asking any, so I'm just gonna move on. It makes these lessons much shorter than class time. Okay, I am also going to try to recycle the paper, so I'm gonna use the back of this sheet. I hope that's okay. I'm just gonna take a look at the answers for 7 and 10. Okay, question number 7, you actually have to do a little bit more reading, right? It says to improve traffic flow in a city, a bridge will be built over a ravine. The surveyor stands, oops, not a very good triangle, is it? The surveyor stands 35 feet to one side. This angle is 47 degrees, and he's actually trying to find this value here. Find the length of the bridge. So here's my bridge. I want to find this. So let's label our triangle. This is my right angle. Therefore, this is the hypotenuse. It's across from the right angle. This is my angle of interest. This is opposite it. This is touching it. So the 35 is touching that 47 degree angle. So that's adjacent. Okay, and again, if I'm looking at SOHCAHTOA, I know adjacent. I want to know opposite. I don't know hypotenuse, and I don't care about hypotenuse. So I get rid of that. And surprise, surprise, it's tan again. This whole section is on tan. Tan 47 equals opposite over adjacent. Tan of 47 degrees equals the opposite over the adjacent. Okay, turn it into a fraction equal to a fraction. So you're going to cross, multiply, and solve. B times 1 equals B, and I have tan 47 degrees times 35. So I'm just going to punch that right into my calculator. Tan 47 times 35. So the length of the bridge is, and again, careful, this question is giving us measurements in feet, so I provide measurements in feet, but always remember I've got a unit there. So the bridge is 37.5 feet. Well, the question actually says find the length of the bridge to the nearest foot. So it was actually 53, so 53 is closer to 100, so I'm going to round up. So if I'm finding it to the nearest foot, the bridge is 38 feet. Okay, and then the last question is a carpenter question, right? Okay, so here's my bad diagram of trusses. Okay, it's telling me that the length here, the height of the truss, is 32.2 centimeters, and that the angle here is 17 degrees. What is the full length of the base of the truss? Does this answer seem reasonable? Okay, so this big triangle here is not a right angle triangle, but this one is, and I haven't done a very good drawing. They should be exactly the same, but whatever, you get the idea. So for this question, it's just a little bit harder than the other ones. What you're going to do is you're actually going to ignore this part of the triangle, right? And you're going to solve for this bottom length of the smaller triangle, and then because it's symmetrical, you're just going to take your answer and multiply it by 2 to find the total length of the truss. So we're just going to ignore this part of the triangle. So really what we're looking at is a triangle that looks like this. These are brand new markers and they're already dying. Let's try a different color, but they're all new, new out of the cupboard. Okay, so what I'm trying to look for is, let's just label this X. That's what I'm trying to find. Okay, so let's label our triangle. This is going to be my right angle if I'm building it properly. So this is going to be my hypotenuse. This is my angle of interest. So this is my opposite. This is my adjacent. Oh, look, it's tan again. But let's just look at why that is. SOHCAHTOA. I know the opposite. I'm trying to find the adjacent. Don't know hypotenuse. Don't care. Surprise, surprise. We're looking at tan. So what do I have? I have the tan of 17 degrees equals the opposite over the adjacent. The tan of 17 degrees equals 32.2 over X. Again, this one's just a little bit trickier. I'm going to put that over 1 so that I have a fraction equal to a fraction. Now I'm going to cross multiply and solve. So I get X times tan 17 equals 32.2. Let's see what tan of 17 is. To 4 decimal places, 3057. Okay, right now X is multiplied by 0.3057, so I need to do the opposite operation. I'm going to divide by 0.3057. What I do to one, I do to the other, so they're going to cancel out. X equals 32.2, 105.3. And let's take a look at those units. Centimeters in the question, centimeters in the answer. Now you'd be tempted to stop here because you're like, oh, I've used SOHCAHTOA to solve my triangle. But remember, you were only solving for this distance. If this is 105.3, this distance is also 105.3. Therefore, your total distance is 2 times 105.3, and we can do that in our head, 210.6 centimeters. Okay, and then the question says, does this answer seem reasonable? I'd say so, right? The truss is about 1/3 of a meter, and the actual length is 2 meters, around 2 meters, so that seems reasonable. Okay, that's it for taking up those questions. I hope that that helps. If it doesn't, feel free to answer on the Google Classroom. You can type some comments in there, remembering to keep them appropriate and relevant, or you can email me at my toolkit email and I will get back to you. Okay, that's it for now. I am going to work on our next lesson, which will be our last word problem with trig ratios, and then we're going to move on to a new unit. So we'll finish up with trig this week. We're going to have some sort of something as a test, but we'll see what that is later. Okay, talk to you later. Bye.